Hello and welcome to another episode of Pokémath. My name is Stefan Eriksson, and today joining me to, fix one of my mistakes I made in a previous episode is no other than Simon Øbro. Hello, Simon.
Hello there.
Thank you for joining me here today, and first of all, thank you very much for pointing out one of my mistakes, because, I didn't do it right, did I?
No, it is really tricky with these mulligans.
It is indeed true. So as we're going to explain this episode, we're going to look into this V-UNION and mulligans. So as you can see up here on the slide here, we're going to talk about this V-UNION math here, and more specifically, mulligans. So first, let me tell you guys what actually happened in the previous episode for those who haven't watched it yet or a little rusty on it. I was calculating the probability of, not pricing some V-UNION pieces, either 1, 2, 3, or more, right? And that was all nice and fun and correctly done, I would like to say, up until the point I introduced mulligans. Because while I do somewhat correct for mulligan, I don't do it correctly. As Simon is going to explain here a little later, sorry. My English today, it's still early morning here. And I used a thing I did in episode 2 where I corrected for pricing, say, or starting with a dedenne in my case. However, the case is a little different here, as we're going to explain. So PM, as we're going to use here, is the probability of mulligan. Actually, we're going to use the complement of PM a lot today. So we're going to have the probability of not having a mulligan, which we're going to call PMC. And then we're going to, of course, this number of mulligans obviously will depend on how many Pokemon you play in your deck, as we're going to show with a couple of examples here at the end. That was enough for me introducing here today, so I will now throw it over to Mr. Øbro. Øbro, the floor is yours here on slide number 3.
Yes. So the problem with the probability, the way we corrected for probability of mulligans earlier was that in the second video Stefan made, it was already given that we drew a basic Pokemon into a starting hand. I think the example was starting with a lone dedenne. Mm-hmm. So we knew that if we had a lone dedenne, we would certainly not have a mulligan hand. But that is not the case in this scenario, because we can still have a mulligan hand even if we price or do not price any of your V-UNION Pokemon.
That's indeed a good point you're pointing out here, Simon, because even if you have a single V-UNION piece in your hand, like a piece of the Mewtwo, that's not considered a basic Pokemon, of course.
Exactly.
And that's where I tricked myself. And you were so nice to call me out and say, hey, Stefan, you messed up. Now, you helped me and correct this here. Brilliant math. And what we're looking at here is we play 4 V-UNION in a deck, of course. You can only play 4. You can't play more. And playing less makes no sense. Let's just get that out of the way. And we have B number of basics in your deck. So what are we actually looking at here, Øbro?
Yes, so we want to also clear up that in this, the way we set it up now is we look at the probability of not pricing any of the V-UNION Pokemon. Yeah. Not to be confused with the result from the earlier video that was the probability of pricing at least one.
That is true. So the whole, sorry.
But it comes out to, they give, they add up to 100% these two probabilities. So it's just the opposite probability we're looking at.
So what you mean is we're basically doing 1 minus whatever I found in my previous episode will give us what we have here today. Perfect.
So we want to find the probability of not pricing any V-UNION Pokemon, given that we do not have a mulligan. So we kind of have to sort away all the combinations where we do not price a V-UNION card, but also have a mulligan hand. Those hands are not considered valid for starting a game of Pokemon. So we kind of have to get rid of those scenarios.
That is indeed correct. So to recap here, we're looking at the probability A we denoted here to be the same as the probability A I had in the previous episode, given, and this is where it's important, given we do not have a mulligan. And now, how do we do this, Simon? And so what is the method now, actually, the correct method?
Yes. So we move on to the next slide.
Yep, that was indeed my key to. I am scooching down to the next slide because how do we do this?
So we have this notation with the vertical line, say the probability of A, given that this MC that we call the probability of not having a mulligan.
Indeed.
And by definition, these conditional probabilities are as written in the third line.
Yep.
And the trick we use to do this is that we take MC, the probability of not having a mulligan, and we split it up into some smaller pieces, which here are the probability of drawing 0 V-Union card into your hand and not having a mulligan, combined with the probability of drawing 1 V-Union card into your hand and not have a mulligan, and so on. We split it up into these 5 different smaller cases, which in combination adds up to the whole case of not having a mulligan.
So what's the secret here, Simon? They're not overlapping, right? That's the secret here.
So of course, if you can't both have 0 V-Union card in your starting hand and have 1, it must be either 0, 1, or up to 4 V-Union cards.
This is where I would like to ask the viewers if you have any objections to this or can prove us wrong on this here. I will be happy to see it. So the whole statement here builds on you can't have both 0 and 1 at the same time in your hand, or 2 in the same time as 0 or 1. They're all separate events from which we combine them all. We get this MC as seen on the slide now. That is indeed the method we're going to be using here. But again, if you guys disagree with this, feel free to post in the comment section below. We're happy to hear your argument against this one here. Although I'm pretty sure I have to revisit my entire math education if this is wrong. So you're absolutely spot on, Simon. So and then sorry, Øbro, my bad. I'm not doing very well on this today. And we used indeed the formula for the conditional probability, which indeed was given here in line 3. Thanks, Simon. And what do we then do? What's coming up now then?
So yeah, we get this huge calculation, the probability of these 5 intersections of probability of A, not pricing any V-Union cards, and then these specific probability of not having a mulligan while having a specific number of V-Union cards in your starting hand. So that's the formula we're going to be using.
And I will scooch down to the next slide just so you know. Then what's the problem with all this now then? Because it seems easy, but it's not, I guess.
So the problem earlier was that these 2 events were not independent. It's really easy to calculate things with independent events. As you've seen earlier in Stefan's video, you can just multiply those probabilities together. But that is not the case when events are not independent. And these 2 events were not independent to begin with, because the number of V-Union cards you draw into your opening hand has an influence on the probability of pricing none of them afterwards. For example, if you draw all 4 of your V-Union cards into your open hand, you're going to be guaranteed to price 0 of them afterwards. But if you draw 0 into your opening hand, there's a higher probability of one of them ending up in your prices.
Seems good to me. Seems correct to me.
So yes, by splitting this MC into smaller cases, we can dictate how many cards we have to draw prices from, and how many of them we cannot draw. Cannot draw the reunion pieces in this case.
And that's indeed how we turn these from, well, seemingly dependent events into sort of, split them up and get independent events again. And by getting these independent events, as you already said, that makes the calculations a whole lot easier, because you just multiply the things together and then, well, we're pretty much there. But there's still some calculations to go. I'm not going to say that this is it yet. So what are our independent events, Øbro?
Yes. So yeah, we can draw. I'm guessing we're on the.
Indeed, I scooched over to the next one here. So we have, you already explained it, right? You already explained what happens if you have, say, all your V-Union cards in your hand or you have none. And what people will see listed here is actually all the different cases listed, starting with if we have 0 V-Union cards in our hand, well, then we have 53 cards left in our deck. And how do we get 53 again? Like, please take me through this here, because what are the numbers here that I'm looking at?
We have 60 cards in our deck, and we drew 7 of them into our opening hand, so we have 53 cards left in the deck. However, 4 of these, since we drew 0 into our opening hands, the union cards, 4 of these we cannot draw. So there are only 49 cards left to select prizes from. And this next case would be if we had 1 card in our opening hand, there would be 53 cards left, and only 3 of them that we cannot prize. So that would be 50 cards in total that we could select prizes from, and so on. And you will see this number that we can select prizes from. It increases by 1 for each the union card we have in our hand.
And this is how we get these 5 separate events again, right? So this draws exactly back to these probabilities that you split up into 5 different cases, of course. And as the viewer now can see, of course there's a pattern here. So I show the first 2 and then ... and we show the last one. If you wish to calculate how many there is in the in-between cases for 2 and 3 V-Union cards, be our guest, but hopefully you can see the pattern going on here. And then, of course, we need to calculate these events, Simon. And on my screen now, I see the one we called MC0. And take me through that one. What happens here?
An example of how the calculation would look for the case of 0 V-Union cards in our opening hand. The probability of pricing 0 of the remaining 49 cards. We see a case of the hypergeometric distribution, where we have 49 cards left to draw, and we want to see how many ways can we draw 6 out of those that are the 6 prize cards. And we divide that by the total amount of way we could draw 6 cards from these 53 cards. That is going to give us the probability of not pricing any V-Union cards, these 53 cards.
Which we indeed call probability A. And yes, as the viewer here will quickly see, then you see indeed here we can just use the rule of independence, in the sense that we got now 2 independent events from which we just multiply the 2 things together. The probability of A, that I have calculated in the previous episode, so that's basically reusing this idea. But now comes this whole probability of PC0, or MC0, my bad. So the probability of not having a mulligan with 0 V-Union cards in your prices, right?
Yes.
Good. Then I'm also on the same page as you. And then so that already pretty much explains what is probability of MC0, and we of course have a lot of different sums going on now, because now it becomes maybe for a lot of people a little complicated, but hopefully Øbro here can take us through a few steps that should make it digestible.
Yes. So you see a lot of binomial coefficients here, which are part of the hypergeometric distribution that Stefan has used a lot of in his videos earlier. So this here is the probability of the 4-0. It's the probability of drawing 0 of your 4 V-Union cards into your opening hand. And then we want to draw at least 1 basic Pokemon. That is the I. So we split this also into 7 different cases, where we first draw 1 basic into our open hand, then 2 basic. If we add all these together, we get the probability of drawing at least 1 basic. Then we multiply that by the probability of filling the rest of the hand up with cards that are not basics. That is the 60 minus 4 minus basics. and then we divide that by the total number of combinations which we can draw 7 cards out of 60 cards.
And I can already tell the viewer that that number is pretty large already. So for
Yes.
people who don't have an idea of probability already, when you just sit with a deck of regular cards, a normal deck of cards is 52, right? Excluding jokers. But Pokemon, you're sitting with 60, no more, no less, which makes the number of possibilities, or combinations in this case, rather large, really quickly. So, and as Simon explained, indeed, we're basically just segmenting our deck. That's the way I would, that's the way I understand it. And now I'm going to the next slide now, Simon, or Øbro, sorry. And then here we can see that we can, of course, we've shown 2 formulas, and now we can, of course, generalize it. Not just for the case of PMC0, but basically PMC, well, N. N being the number that we don't price, right?
Yes.
Or we price. Now,
the
have to be careful.
The union card we draw into our opening hand.
That. Very good. And then we get, yeah, you basically explained it already, but for a lot of people, this, you just have to imagine this sum that you see here is basically just different cases that you calculate, and then you add them all up together. So you have a case with where, of course, we have a given number of basics in your deck, and then we have how many are we, well, drawing. How many are we drawing of these V-Union pieces? And of course, we're just only in this case considering one V-Union set in your deck. That's very important to point out right now, because it may be a little different if you play different V-Union sets, of course, and that would be fun for another time. But I got an example here. Would you like to take the viewer through this example, Simon Øbro?
Yes. So in this example, we calculate the probability with 10 basics. So you see everywhere where we have B or basics written in the formula, we would insert 10. If we do that, you see we get these calculated, these 5 cases separately. So you see the first one is 0.2814. So that is the probability of drawing 0 V-Union card into your opening hand and not have a mulligan hand and not prize any of the V-Union cards at once. And the second one, 0.16, is the probability of drawing 1 V-Union card into your opening hand and at least 1 basic and not prize any of the remaining V-Union card, and so on. If we add all these probabilities together, we get the probability of not pricing any V-Union cards, regardless of how many we drew into our opening hand. And we see that it is close to 48%.
That's quite often. No, that's quite often. That's a quick math would tell you that's about half your games, right? So that's a lot. And yeah.
But bear in mind that these with these probability we did not correct for mulligans yet. So the denominator in the formula has not been taken into consideration yet.
And notice also we have rounded it for 4 decimals. Yes, there are a lot more decimals, but just having 4 minus the last one is actually 0.000, a lot of zeros. I only put 3 zeros there by mistake. But yeah, it just means that it's not 0. It's just very small. That's all we need to have here. And as Øbro correctly says, this is not corrected for mulligans yet. And that's where we go to the next slide, and hopefully that will clear up a few things.
Yes. So these approximately 48%, we have to divide that by the probability of not having a mulligan when we play 10 basic Pokemon. And we see that there's about 74% chance of not having a mulligan. So we divide our 48% by 74 and get the final result, which is close to 64.5%.
And that's great and all. Like I look at this number here and I'm saying, okay, that's really interesting. But there's something for comparison. So indeed, oh yeah, thanks Slowpoke in the slide there. Yeah, correcting my mistake because I'm the one who messed up in the beginning, which is why we're sitting here. And how many basics did I use in my example? I used 15. So I thought it would be a good idea to also run through exactly the same calculation as before. So on the slide now, people would see this very big monstrosity of a formula again. And essentially, we're doing exactly the same now. Only difference being now B is 15 instead of 10. We obtain these 5 separate probabilities. We add them all together, and we get around 57.08% if we translate that into percentage. We can then correct for mulligans, just like we did before, which was, of course, just dividing this by, well, mulligans, which with 15 basics becomes 1 minus this hypergeometric formula here, essentially, giving us that we divide our 57.8%, divide that by 88.25, and we obtain 64.88. And for readability, I put the comparison down below, what I actually got in my episode. And you may notice, oh, Stefan was not so far off, so what's the problem here? That was close enough. But more than 4%, guys, that's a lot. That's already a big miss now. And as when Øbro first contacted me, he gave me a quick example of a boundary issue. Do you remember that one, Øbro?
Yeah, I think I used the formula with an example where we played 1 basic, and it turned out that there was a 300% chance of pricing at least one of your reunion cards.
That's pretty high probability. So yeah, that of course signaled that whatever I was doing there was there was something wrong, which is what led us here. And yeah, that is indeed better. And with that said, this here, hopefully, ladies and gentlemen, and again, a massive thank you to Simon Øbro for joining me here today and explaining this here, because yeah, I didn't see it, and well, that's good that somebody else can call me out and say, hey Stefan, whatever you made there, yeah, that was not all entirely correct. So I'm glad that a fellow Pokemon enthusiast can help me out here. And for those who don't know, Simon Øbro, long-time Danish Pokemon player as well. Normally people know him with a longer beard. I could not remember him right now at this point, so that's quite funny. But anything you want to say to the viewer here, Simon?
Yeah, if I can point out that I think it's interesting that the probability of pricing these V-UNION cards, it decreases as you play more basic Pokemon. So you can make it the argument that if you want to play V-UNION card, you should play as many basic Pokemon as you can to increase the probability that you have access to all of them. But what we see is that whether we play 1 basic or 54 basics, the final probability, the difference between them is certainly less than 1%. So really it doesn't make much of a difference how many basics you play in your V-UNION deck.
I think that's a fantastic takeaway on this here. So yes, theoretically speaking, there's a difference. But remember, ladies and gentlemen, theory is one thing, practice is something else sometimes, right? So with that said, I would like to round off today's episode. And again, a massive thank you, Simon Øbro, for joining me here today. And with that said, I hope to see you guys back for another class here in Stefan's classroom. Bye-bye.